Hi there, Physics 131. This is the pre-class reading video for Class 18. We are finishing off Chapter 6 today on impulse and linear momentum. So Section 6.5 is skills for analyzing problems using impulse and momentum. And there's a problem-solving strategy, and they give a example 6.4 of a bullet hitting a wood block. So this is sort of like a collision. The bullet is moving along, then it gets embedded into the wood, and so it stops relative to the wood. And they draw this dashed line around the system, defining the system to include the block of wood and the bullet. So the sketch and translate system is you sketch the initial and final states. That's typical for Chapter 6 problems. Then you choose a system, and then simplifying diagrams step, you can write out the impulse momentum theorem. So the initial momentum of the bullet and the wood summed up plus any external impulses equals the final momentum of the bullet and the wood. So it's good to draw an impulse momentum bar chart for the system in the simplifying diagram step. Then you represent mathematically by going through all the equations. It's just the same equation you wrote down with the bar charts. Initial momentum plus the external impulse, which in this case equals 0, equals the final momentum. And then you solve and evaluate. Solve for your unknowns, check if your answer is reasonable. And so that's a good example to go through. There's an example here about determining the stopping time interval from the stopping distance. This is something you probably could do with kinematics and Chapter 4 stuff, but it goes a little faster and you get a sort of a different way of looking at it if you go through this using impulse momentum theorem. So there's a skydiver hits a cushion. You think about the forces on the cushion and the momentum of the skydiver, which ends up with 0 momentum in the final state. And so I would encourage you to go through that example. There's something about bones breaking, example 6.6. I'm sorry about all the bullets and all the collisions and the people falling. It seems like a rather violent chapter, but luckily what happens with the collision of bicycles is that the person does not, our estimate could have been off by a factor of 10, but the force per area is still too little for a fracture, so he's okay in the end. Section 6.6 is a quick description of jet propulsion, which considers a rocket which is moving one direction and the fuel moving the other direction. If you define the system as being both the rocket and the fuel, if you kind of diagram this out, then they end up going in opposite directions. And so basically, even if everything's at rest at the beginning, there's no initial momentum, and there's no external impulse, you can get the rocket moving if you send off the fuel in the opposite direction, because these plus bars equals these minus bars. So that's the idea. And then if you look just at the rocket alone, it just seems to blast away all by itself. Section 6.7 is called collisions in 2 dimensions. So idea here, if you have things moving, like this is a top view, so y is north, x is east, for example, these 2 cars collide. Remember, the impulse and the momentum are both vector quantities. So what that means is, easiest way to solve this is you just take the x components and set up your equation. The initial momentum in the x direction plus the x impulse equals the final x momentum. And then you have a whole other equation for all the y components. Same thing. Initial y component of momentum plus the y impulse equals the final y momentum. So, and you just have a lot of coses and sines to keep track of. So there's some examples of that. There's objects sometimes exploding or breaking apart into parts. This talks about the radioactive decay of a radon nucleus. So initially you have some radon nucleus, it'll decay into an alpha particle and a polonium nucleus. So, and the momentum there is conserved in that radioactive decay. And that is often how a lot of these questions in Chapter 6 work. There's either a collision, so a fast two objects coming together, or there's an explosion, a fast separation of two objects. And that's it actually for chapter 6. This is the summary, talking about what an isolated system is. It's isolated if there's no net external forces. If it's got an external force from some part of the environment, then it's not an isolated system. Mass is a conserved quantity, and momentum is a conserved quantity if the external net force is 0. So there's the definition of momentum. There's a lot of nice little equations here, such as initial momentum plus the impulse, which is the change in momentum, equals the final momentum. That's the main thing, and a little review of how to use those momentum bar charts. So that's it for chapter 6 and for Friday's reading. I'll see you on Monday. Bye.